In this next example, I have a guy shooting a rifle, and we have a rifle shooter, Hugh. He fires a shot, and he hits the target 80% of the time. If Hugh fires 4 shots at the target, we want to determine the probability that he has these two things. We got a part A and a part B. And I think I gave myself 2 slides for this. Yeah, okay. So let's take care of part A first. I want to know the probability that he hits 2 times and misses 2 times in any order. This any order piece is what's just signifying that I'm talking about combinations and not permutations, right? So that's the only piece to this. And this binomial probability works out with combinations because I'm looking for different ways that I can group the same outcomes together. So if I were looking for exactly hit, hit, miss, miss, that would be a different way of calculating that, which we're not going to talk about. So that any order is basically what I'm looking for. So nothing really changes for my process. So first, let's see the probability of the event occurring is equal to 0.8. I can write down the number of the number of successes I'm looking for is 2, since I want 2 hits, and the number of trials is equal to 4. So let's switch colors up here, and I want to find the probability that this event occurs exactly 2 times. Is going to be given as 4 choose 2 and choose R times 0.8 to the second power, the number of successes, times 0.2 to the second power, the number of failures. So let's type that into the calculator, and that's going to be given as, let me go to math, probability, so 4 choose 2, and that's times 0.8 squared times 0.2 squared. And that comes out to be 0.1536. 0.1536. So that's the probability of this event, or this situation occurring, where Hugh hits it twice and misses it twice, in any order. All right, so he's got about a 15.4% chance of that occurring, even though he hits the target 80% of the time. Now, what's interesting about this is that you might think, well, that seems kind of low. But really what we're doing is, if he hits the target 80% of the time, it's actually more rare that he would miss it twice. So let's see actually what would happen if we calculate at least 2 hits. This is going to be a little bit different because I need to think about what that at least piece means. What that means is that I can, what I'm looking for of the probability, or what I'm looking for is the probability that the event occurring will equal 2 times, but I also want to add that to the probability of the event occurring 3 times, since that 3 hits would be encompassed in the at least 2 hits, and I want to also add that to the probability that the event occurs 4 times. So all of these 3 probabilities added up together is going to give me the probability of at least 2 hits. And it should make sense that I can just add these up. If you think about that binomial expansion, the only term that I'm really missing on this is, or terms I should say, would be 1 hit and 0 hits. So that's basically what I'm doing here. I'm adding up these individual probabilities, and that sum should give me the probability of at least 2 hits. So we know what this one is. We know that this is that 0.1536. Let's find the probability of the event occurring 3 times. And that's going to be given as 4 choose 3 times 0.8 to the third power times 0.2 to the first power. And then the probability, let's actually get what that's equal to right now. Go back to our calculator, and let's see, I'm just going to change a few numbers here. So this is going to be a 1 on the 0.2. That's going to be a 3 for that exponent. And we'll change this to a 4 choose 3. So that's going to be 0.4096. And then let's go one more color here. The probability of this event occurring 4 times is equal to 4 choose 4 times 0.8 to the 4th power times 0.2 to the 0 power. And that's going to be, now 4 choose 4, well, let's just type this in here. I'll just change all of my exponents. We know that this should be equal to 1, so I don't really need to include that. That should be a 4, and I'll change this to a 4. And that equals, that also equals 0.4096. All right, so that's going to be 0.4096. So when I add that, let's take the probability of the event occurring exactly twice, and we'll tack that on the end. So the probability of the event occurring twice equals 0.1536. So let's add all these things together. So I've got 0.1536 plus 0.4096 plus 0.4096. That equals 0.9728. So this is all going to equal and I'll list this as the probability of the event. When I say at least 2 times, that's really greater than or equal to 2. And that's going to be equal to 0.97, I can't remember what it was, 9728. So a little bit different notation here, but hopefully you can see what this means. I want to know the probability of that event occurring greater than or equal to 2 times. So a little bit more work on that one. We had to kind of conceptualize what all the different successful scenarios are. That's why I had to break it up into all 3 of these events and then add up those distinct probabilities, but really not all that crazy. So for the last you try example here, give this one a shot, pause the video, and again, think about the concept and what you're choosing, what your successes are, what your failures are, and the probability of those items. So pause the video, give this one a shot. And here are my final solutions here. I've written out what the probabilities are in the binomial probability equation, and also what I've typed in the calculator. And here are my probabilities: 16 out of 81, and then 8 out of 27.